Hello and welcome back. This will be the last video for chapter 16, and I'm just doing this for the extra people who may need a little extra help. So if you're doing really well on this, still watch it because it'll just make you better. Okay? If you're not doing too well, okay, spend some time watching this, maybe a little extra time doing this. Okay, so this goes back to that problem with the insurance companies. This is their payout for each person for a particular life insurance plan that they have. Okay, so the question is, if 10 independent people buy a policy, what's the probability that the insurance company will pay more than $400? So whenever you have questions like this, you want to make sure that each X is independent and that that they're normal too. You have to have normality, okay? Because when you're finding probability, at least for right now, you have two ways. You could find it on a probability table or a curve. So if it's on a probability table, you just kind of use the boxes. But if it's on a curve, um, for right now, and for most of the case in this class, it has to be normal because that's how we use our z-scores, okay? And even the last video, I forgot to use the notation, and so you want like the probability of um, the event that we want. We want to turn that event into the random variable into a z. Okay, so the probability that x was greater than, I can't remember what it was, but oh, the zero was, so it was the probability that x was greater than zero because that was the swim times, and I turned that into a z, which was like 0.44. I forgot to write that on the last video. I'll write it here though. Okay, so um, so here, 10 people, and what's the probability that the company will pay more than $400? So you could kind of see where I'm going, because if 10 people buy the policy, how much would they expected to pay? So if 10 buy, okay, a policy, how much does the company pay out? So you don't even need notation for this. The company pays on average, on average, okay, $200. You see that, right? So that would be your mean of your 10 people. So I'm going to say something like this. If there's 10 people, then I'm going to say T equals x1 plus, this is the second person buying it, the third person buying it, all the way to the last person buying it, okay? So the expected value of the total would just be the sum of every one of these, okay? Because ET equals expected value of T1 plus, or x1 plus all the way to x10. That should be a 10 because there's 10 people, all the way to x10. And I'm just using the formula here. x1 plus all the way to the last person. Well, for each person, the company has to give $20. So they have to give $20 to 10 people. So they're expected to give out. So like we were saying, you have 10 of these, so this should be $200. $200. Okay, so the harder one is the standard deviation. Okay, so the standard deviation of t. Okay, we really need to find the variance. So that's the variance of t. And don't get confused. Remember I said that each x is not, it's not 10x. 10x would be increasing the premiums by 10. This is 10 different people, lower risk, lower standard deviation. So this would be the variance of x1 plus all the way to the variance of x10 all the way to x10. So what's the variance? 387 squared plus 387 squared. And how many of these do I have? You could do it. You could guess. How many 387s do I have? I can't hear you, but I'm sure you're saying we have 10 of these. Okay? It's amazing. You learned this in the second grade. When you have a lot of the same numbers, instead of add them all, you could use multiplication. It's great. Okay? So that's my variance. Okay? 387 squared times 10. So let's go ahead and just do that out. I won't. Oh, I must have shut my calculator off. I wonder if I have the squared button there. Okay, it came back real quick. Okay, let's get this situated. Of course, it disappears. View, always in front. Okay, so let's find a place for this, and we'll do 10 times 387 squared. So 1497690, and as we know, the standard deviation of that number, okay, is just the square root of that. 1497690. So I'm just gonna second x squared, which is the square root, and then I could second answer it, which puts the answer in there, and I get 1223.801. Okay, and this is money. Okay, so now I'm saying, now I have a normal curve because I told you that they were normal, so they're all normal. So I have a normal curve. I'm expected to give out 200. Okay, so this is normal with 200 and 1223801. And you're going to see why this is really nice. So I'm going 400. What's the probability that it's paid more than $400? So that's over here again. Okay, so what's the probability that t is greater than 400? I'm going to use the notation here. That equals the probability that z is greater than something. Okay, the probability that z, because I have to do this, I have to turn this 400 into a z. So z equals 400 minus 200 divided by how much variance is going on here. 1223801. I'm gonna actually store this number so I could use it. Not like that. So store. I stored this number here in A. Okay, so it's 400 minus 200, which is 200. Okay, divided by, and I put this number in A. So it would be second, not second, alpha A. There we go. So my Z is 0.16, and I just normal CDF that. Normal CDF and then a big number. See this number? Normal CDF, comma, big number. So there's a 43% chance you'll pay more than 400. So it sounds pretty bad, but the reason is because 10 people is just not enough. Okay? So what happens if I do this for 1,000,000 people? Let's say I got 1,000,000 people to buy this policy. Okay? You could try it. Try it with 1,000,000 and see what you get. Try with 1,000,000. And I have a feeling that this number will be way down. Okay? Because less people is more risk. If you had 1,000,000 people, the chance that you'll pay more than you expect to pay will be a lot smaller. Okay, and I'll do this one really quick. X is the length of a song. The average song length is 4.3 minutes, and standard deviation is 1.3 minutes. What's the probability that 40 songs will be less than 140 minutes? Okay, so here we go. I have a normal curve. The songs are independent, and the songs are normal. Okay. The reason we need the independent one, well, we're not combining any. Yeah, we are combining. We're combining 40 songs. You have 40 X's. You have 40 X's. So we're combining those. So these X's have to be independent. Okay? So the middle is 4.2. Oh, I'm sorry, the middle is not 4.2. If every song is 4.2 minutes, and now this is 40 songs. Okay, so if on average they're 4.2, that's going to be e to the x1 plus all the way to x40. Okay, which is going to be there's 40 x1s. There's 40 e to the, I shouldn't write this. This isn't a good formula. E to the x1. There's 40 of these. Okay, so each one of this is 4.2. How many 4.2s do I have? 40. So it's 40 times 4.2. So the average song length for 40 songs is 40 times 4.2. Enter. 168. 168 minutes. So I'm saying, what's the probability that the 40 songs will be less than 140? So I'm saying the probability of t equals all these x's, and all these x's represent each song. So the probability of t will be less than 140. 140. Okay, so this is normal. 168, and I still have to find the standard deviation. So to do standard deviation, we have to go through the variance of all these x's. Okay, x40. This is not like 40. This is not equal to 40x. 40x would be making one song 168 minutes. One song 168 minutes. This means you have 40 different songs that are 4.2 minutes. You have to understand that. Okay, so that you know to split these variances up. So the variance is 1.4 squared plus 1.4 squared. How many of these 1.4s do I have? We have 40 of them. So it's 40 times 1.4 squared. Okay, that's the variance. So the standard deviation of the total equals the square root of 40 times 1.4 squared. So I'll put it in my calculator. 40 times, I'm trying to go as fast as I can. Okay, that looks right. So it's 8.85. 8.85, and both of these are in minutes. Remember, the standard deviation and the mean are always in the same thing. So 8, it doesn't look like it's going to be very likely. Let's see, 40 to 50, 50 to 60, because this is 28 away, right? Is this 28 away? 40 to 50, 50 to 60, that's 28 away. But if you look, a standard deviation is, let's just say 9, okay? So this is almost 3 standard deviations away. So I could actually put this a little farther. I could put this a little farther away. I could put this over here. 140. Okay? So how often are those 40 songs going to be less than 140 minutes? Okay, so I need to turn that t into a z. And I already got a rough idea of what the z is, okay? So z equals 140 minus 168 divided by 8.85. Okay, so that's negative 28 divided by 8.85, which is negative 3.16. Okay? Negative 3.16. And I'll just put the answer here. That's my answer. So to get the answer, second distribution, down to normal CDF. Now remember, I'm starting over here and working my way this way. Okay, so this is my start. This is my stop. And I'm not dealing with x's, I'm dealing with z's. So I say negative, a really, really small number, comma, and I want to go to my z-score, which was negative 3.16. Close it. It's going to be pretty small. It's going to be 0.0000788. Okay, so really small chance that 140 songs will be less than 140. Okay, So that's it. That's it. Hopefully you have a good grasp on this stuff, and have a nice day.